today we're going to review our lesson about trigonometry. So if you'll take a minute and copy down these definitions, there'll be a couple things that you'll have to know about trig. First of all, just the 90-degree ratios. So if we have theta, we should remember that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Remember their reciprocal functions. Cosecant is the reciprocal, secant is the reciprocal of cosine, and cotangent is the reciprocal function of tangent. Also remember that if we have legs, the opposite squared plus the adjacent squared equals the hypotenuse squared. So I'll give you a couple examples of one where we have to find a leg in a triangle and the other where we'll have to find the angle given two legs. So first off, I'll give you a right triangle. The angle will be a 20-degree angle. Let's say x, y will be 90 degrees, and I give you another leg is 15. So in this case we have a triangle XYZ. We want to find side x. So looking at our opposite and adjacent, that would be the tangent function is opposite over adjacent. And if we wanted to solve for x, we'd just multiply both sides by 15. So x will equal, and again, be very careful that your calculator is in degree mode. You can check that always by just hitting mode and then making sure you're on degree. 15 times the tangent of 20. X will equal 5.4. 9 is bigger than 5, so we'll round this to 4/6. The second type of problem you'll have to do with the right triangle is to find an angle. So I'll give you A, B, C, and let's say the hypotenuse is 15 and the adjacent leg is 7. We want to find angle A, so let's set up cosine. Why cosine? Because cosine is adjacent over hypotenuse. So cosine of A equals 7 over 15. When you want to get rid of a trig function, remember we'll do the inverse. So that gets rid of the cosine, so A would equal cosine inverse of 7/15. Again, making sure that we're in the degree mode. Cosine inverse of 7/15 will give us angle A's measurement as 62.2 degrees. The second type of triangles you'll work with is non-right triangles, and when we have non-right triangles we'll use what's called the law of sines and the law of cosines. So take a minute and copy down your two law of sines. And you can see we're going to use this law when we have a non-right triangle. So if I give you that angle A is 95, the side opposite A is 15, B is equal to 7, and we're going to be asked to find angle B, excuse me. So we'll use the law of sines where angle B is in the numerator, and we'll plug in what we know. So sine of 95 over 15 equals, we don't know what the sine of B is, over B we do know. So we'll use a little math and we'll try to find what sine of b is. So we'll multiply both sides by 7. And that's what the sine of b will be. Please punch with me because this is a little awkward. So we'll go 7 times the sine of 95. Make sure you end that. All divided by 15. And this is what the sine of b will equal. So again, remember to get rid of the trig function, sine, we'll do the opposite, sine inverse. So we'll take sine inverse, and again, the easiest way to punch this in is just to hit second and then answer. And then angle B will be 27.7 degrees. Another example of using the law of sines is when we have two angles and we need to find a missing side. So again, let's look at the law of sines where angle A is in, side A is in the numerator. So we'll switch our law of sines and we'll put our angles on the bottom and our sides on the top. So again, we want to solve for A. So let's put in what we know. A we don't. Sine of 62 equals 100 over the sine of 100. Nope, sine of 17, excuse me. Sine of 17. And again, we want to solve for A, so we're going to multiply both sides by the sine of 62. And please punch with me because we're going to multiply 100 times the sine of 62. We'll end that and then divide by the sine of 17. So side A should equal 300 and rounding off 302.0. And again, let's see if that makes sense. If angle B is only 17 and it's 100, then angle A being 62 should make side A a lot bigger, and it is at 302. The last trig that we used in solving for a triangle was the law of cosines. So write down again these two law of cosines. We'll use this with non-right triangles. And if we're given two sides and an angle, we'll use this one. And if we're given three sides to find an angle, we'll use this one. So this will be a side, side, side. This will be side, angle, side. So the first example I'll give you angle C is 123 degrees. A side is 7, B side is 9, and you're going to be asked to find side C. So let's set up the formula. We have an a squared plus b squared minus 2ab, and then take the cosine of C, which is 123 degrees. So basically, we will just set this up, punch out the formula just the way we see it. But we'll have to remember that this is what C squared equals, so we'll have to take the square root of that when we get the answer. So again, I always encourage you to punch with me. So 7 squared and 9 squared minus 2 times 7 times 9 times the cosine of 123 is going to be 198.6. But the extra step here is this is C squared. So we'll have to take the square root of this to get side C. So again, try to make just some sense. Does this make sense that if this were 7 and 9, that side C is across from the biggest angle, so it should be pretty big. The last trig question on your exam will deal with finding an angle of a non-right triangle. given 3 sides, and this time I'll ask you to find angle C. So we'll use our law of cosines that has C in it, which is a squared plus b squared minus c squared all over 2 times ab. And I'll give you these formulas on your exam, but again, you'll have to be able to know how to use them. So let's plug in first what I know. So a squared is 14, b is 17 minus 29 squared all over 2 times 14 times 7. Make sure you punch these in with parentheses, and we'll have to remember that this is what the cosine of C is. So we'll have an extra step here, and let's punch first. So the numerator divided by the denominator. This is what the cosine of C equals. So remember, if we want to get rid of the cosine, we'll have to take the cosine inverse of both sides. The easiest way to do that is to cosine and then get your second answer. So angle C should be 138. Let's round off to the nearest tenth. And again, this should be a pretty big degree because this 29 side is a very big side.